In this video, we're going to start looking at logarithms. A logarithm is the power a base is raised by to give a particular value. The easiest way to see this is by writing an exponential statement. An example of an exponential statement could be 5 to the power of 2 is equal to 25. Or if you like, 5 squared is 25. This is the base. This is the power, or if you like, the index, or if you like, the exponent, and this is going to be the particular value we get. This now is an exponential statement. If I wanted to write the logarithmic equivalent, I could say log to the base 5 of 25 is equal to 2. So here we've got now the base. Here we've got the particular value, so that's a value, and here we've got now the power. So let's go back to my original statement. The logarithm is simply the power the base is raised by to give a certain value, and we can see this here. This is the power, and we would say now that log to the base 5 of 25 is equal to 2. In general, if we have now an exponential statement a to the power of b is equal to c, the logarithmic equivalent now can be written as log to the base a of c is equal to b. We say now that a is going to be greater than 0 and a cannot be equal to 1. So we need a to be now a positive value. So let's look at this and the relationship between the two. These are inverses. So what we'd have now, if we had it graphically, is the following. We could have now an exponential curve, and that exponential curve, let's do y is equal to 2 to the power of x. That would come round like so and come up and get very steep very quickly. This point is going to be 0, 1. What I'm now going to draw is y is equal to log to the base 2 of x. We will have now a reflection in the line y is equal to x, and it will look something like so. This point here is going to be 0, 1. This point is going to be 1, 0. If we consider now, if I have log to the base 2 of 1, all I say to myself is what power do I need to raise 2 by to get 1? Well, the answer is 0, because 2 to the 0 is 1. So here, what power do I need to raise 5 by to get 25? The answer is 2. So that's the point now, 1, 0. If we look at this point just here, we'll have now x is equal to 1. Well, if x is equal to 1, 2 to the power of 1 is going to give me now 2. So we got now 1, 2. If I consider x is equal to 2, what power do we need to raise 2 by to get 2? The answer is 1, and we'll have now the point just here, and that's going to be now the point 2, 1. We can see this is reflected in the line y is equal to x, so the coordinates change over. So hopefully you can see the relationship between the two. What we just saw here is that log to the base 2 of 2 is 1. In general, we can say that log to the base a of a is going to be 1. What power do I need to raise a by to get a? Well, quite clearly it's 1. If you want to look at this now and just put the power between the two, 5 to the power of 2 is 25, a to the power of 1 is a, it might help you remember. Another result we've got, log to the base a of 1 will always be 0. If we just consider now, what power do we need to raise a by to get 1? Well, the answer is going to be 0. If we just consider now, 2 to the power of 0 is 1, 3 to the power of 0 is going to give us 1. So the logarithm is the power this base is raised by to give the certain value. So that's what we have. What we're going to do in this video is just look at writing exponential statements from logarithmic and vice versa, and then evaluating some basic logs. Before we go on, I've introduced this. I just want to introduce a little bit of notation. We can write now log to the base 10 now as just log. If you look on a calculator, what we'll have are two buttons here. we'll have log and then log to the base of. This one just here is log to the base e, or the natural logarithm. In later units you'll study that. For now we're just going to consider these two just here. So if I put log in here, log of 10, this is saying to me, what power do I need to raise 10 by to get 10? The answer is 1. If I now did put this in, what we've got here, this is exactly the same, so I'm putting the base in. That is going to give me 1. Quite clearly, if I change this over to 0, that's going to give us 2. If I changed it over now on here, and I'm going to write the following, 1 over 10, let's write this in, 1 over 10, this is going to be negative 1. We know now that if we have 10 to the power of negative 1, this is going to be 1 over 10 to the power of 1. Therefore, what we can say now is log to the base 10 of 1 over 10 is equal to negative 1, or we can just write log of 1/10 is equal to negative 1. So this now is a logarithmic statement based on this exponential one. We could look at other logarithms. Now these are giving nice numbers. If I said now log to the base 2 of 5, well, this isn't going to be an integer value. This is asking me what power do we need to raise 2 by to get 5. Now if we consider 2 squared is 4, so this is going to give me 2 point something or other, 2.32, and we might be asked to round that now to 3 significant figures or 2 decimal places. So all of these are not always going to be nice. Yet if I put in here log to the base 2 of 16, what power do I need to raise 2 by to get 16? Well, the answer is 4, and we know that because 2 to the 4th is 16. So hopefully you can see how we can work between these. I'll just put another one in, see if you have got anywhere with this. Right, log to the base 2 of 0.25. This is quite nasty, quite tricky. If you want to go at it, and then I'll show you how we get the answer. Okay, the answer should be negative 2. The reason being, if we take this, this is log to the base 2 of 1/4. So what we want to do is find the power 2 is raised by to get 1/4. Well, we know now that 2 to the power of negative 2 is going to be 1 over 2 squared. So 2 to the negative 2 is going to be 1 over 4, or if you like, 0.25. Therefore, what power is 2 raised by to get now 1/4? The answer is going to be negative 2. It's important to stress now that we can't take the log of a negative number. We call the values of x that we can put into this particular function or graph the domain. We can see now that we can't take negative numbers because when we have an exponential statement or exponential function, it doesn't yield negative numbers. So for example, if I wrote now log to the base 2 of negative 6, well, no power of 2 is going to give us negative 6. So taking the log of a negative number does not give real solutions. So let's go ahead and just do a bit of work with these and look at simplifying, rewriting, and so on and so forth. We're asked to write the following in the form log to the base a of b is equal to c. So we've got this now in the equivalent exponential form. So if we look at this now, 2 to the power of 3 is equal to 2 to the power of 3 is equal to 8. So all I'm going to do is write a log to the base 2 of 8 is 3. Remember, 3 is the power the base is raised by to give this particular value. We're just writing the logarithmic equivalent. Here we've got the base of 7. So we would write log to the base 7 of the given value, 49, is equal to 2. With this one here, we've got now log to the base 4 of 16. Well, 4 to the power of 2 is 16, so we would just write it like so. This one just here, the base is 3, log to the base 3 of 1/9, which I'm just going to write as 1 over 3 squared, is going to be equal now to negative 2. We know that 3 to the negative 2 is going to give us 1 over 3 to the positive 2. Okay, this one right here, we can say this is log to the base 6 of 1 is going to be equal to 0. All we're doing is rewriting this. This is the power 6 is raised by to give us 1. If you want now, and I'll just change colour, it's not mathematically very legit, but you can jam that in there and say 6 to the 0 is 1. 3 to the negative 2 is 1 over 3 squared. 4 to the 2. So hopefully you can see what I'm saying at this point. So what we've got here is a subscript, and then we have this quantity. So let's just go with these. Right, the next one. We've got now on this one log to the base 10, and we could of course just write log of 0.001 is going to be equal to negative 3. I'd prefer to see this now as log of 1 over 1,000. Okay, 1,000, and that is exactly the same. That looks a lot cleaner. What power now is 10 raised by to get now 1 over 1,000? Well, the answer is negative 3. Okay, this one now, we've just got p to the q is equal to r, so we can say now log to the base p of r is going to be equal to q. Because p to the q is r, therefore we can say log to the base p. The base is p, the value is r, and now the power is going to be q. So that's now writing a logarithmic statement given the exponential. What we'll do is just go backwards and write the exponential given the logarithm. So log to the base 5 of 25 is 2, therefore we can say 5 squared is equal to 25. Often students who are not confident will prefer to work this way because they know 2 to the power of 4 is 16, so it makes sense that log to the base 2 of 16 is 4. So 2 to the 4th is 16 on the next one. All we're doing is just writing it. Remember, if we have a to the power of b is equal to c, that is the exponential. The logarithmic statement is log to the base a of c is equal to b. So this one now we can say, remember this is going to be log to the base 10 of 1 over 10 is equal to negative 1. So we'd write this now as 10 to the negative 1 is equal to 1 over 10. So I'm just writing now the exponential equivalent. This one, log to the base t of s is equal to r. Therefore we can say t to the power of r is going to be equal to s. The logarithm is simply the power. The base is raised by, here's the base, so that's the base, to give a certain value, and that is the value. I'm using value, it's not a technical definition per se, but hopefully gives you some idea. Right, okay, let's go ahead and look at some others. We're asked to evaluate the following without a calculator. Log to the base 2 of 32. All I'm asking to myself is what power do we need to raise 2 by to get 32? Well, the answer is going to be 5. If we just think about this now, what number do I have to put here? 2 to the power of what is 32? That's 5. Log to the base 5 of 5, well, log to the base a of a, that's always going to be 1. What power do I need to raise 5 by to get 5? The answer is going to be 1. Log to the base 8 of 1. What power do I need to raise 8 by to get 1? The answer is 0. 8 to the 0. So the equivalent statement is 8 to the 0 is equal to 1. The equivalent statement here is 5 to the power of 1 is equal to 5. The equivalent statement is 2 to the 5 is equal to 32. Okay, this is going to be log to the base 10. Remember, we've just got log. So what power do I need to raise 10 by to get 1,000? Well, the answer is going to be 3. So I could say now the equivalent statement in exponential form, 10 cubed, is going to be 1,000. Okay, this now is quite nice. What we've got here is 9, log to the base 9 of 27. 27 isn't a power of 9. If we just consider now 9, and if we said 9 to some power, let that be x, is equal to 27, well, it's going to be 9, then we're going to have 9 squared is 81. Just consider this as powers of 3. You don't have to do it this way. You could work out to yourself, well, what do I need to do to get to 27? Well, if I take the square root and then cube it, that's going to be my answer. Square root is going to be 3. 3 cubed is going to be 27. Alternatively, what we can do is just write these as powers of 3. So this is 3 squared to the power of x, which is going to give us now 3 cubed. So what we can do, rules of indices, 3 to the power of 2x is equal to 3 to the power of 3. Therefore, 2x is equal to 3, and then x is equal to 3 over 2, if you want. All I've done is said, well, we know these are both powers of 3, so if I take the square root of 9 and cube it, that'll be nice and straightforward. Okay, what power of 4 gives 1 over 64? Well, the answer is going to be negative 3. So if we look at that one, some power of 4 is going to be equal now to 1 over 64. Again, if I write this as a power now of 4, what we can do, we can write this. Now that's going to be 1 over 4 to the power of 3, and then we can have now, that's going to give me 4 to the negative 3. Therefore, if the bases are the same, we can equate the powers, and x is going to be negative 3. So this is just knowing your indices. So that one's 3 over 2. That one is going to be negative 3. Okay, next one. Next one's quite challenging. Again, don't make the mistake of putting something to do with 2, that you're multiplying 8 by 2. We're asking now, we've got log to the base 8 of 1/16. These are both powers of 2. So what we've got then, 8 to some power is going to be 1 over 16. So 2 to the power of 3 to the power of x is going to be 1 over 2 to the power of 4. So what we can say then is 2 to the power of 3x is going to be equal to 2 to the power of negative 4. So we can see that x is going to be equal to, equating the powers as the bases are the same, that's going to give negative 4/3. If you like, you can take now the cube root of 8, which gives you 2, raise that to the 4th power, which gives 16. 1 over 16 is therefore going to be negative, so negative 4/3. Okay, this one right here, this is a bit more challenging, but we'll have a mess about with this. Right, we've got log to the base 27 of 1 over 81. Again, both powers of 3. So let's get ourselves some room to move. So 27 to some power, which I'll call x, is going to be 1 over 81. We're going to have to square this in the end now. And in later videos, we will look at when we have now the argument of a logarithm squared rather than actually squaring the quantity. So these are powers of 3. So what have I got? I've got 3 cubed to the power of x. And then I've got 1 over 3 to the power of 4. So we can say now 3 to the power of 3x is going to be equal to negative 3 to the negative 4. So we can say again from this that x is going to be equal to negative 4/3. So what we need to do here is just square that. So negative 4/3, and if we square that, what's that going to give me now? That's going to give me 16 over 9. So we could, again, you can check this on a calculator. We're not, we're evaluating without a calculator, but even so, if you wanted to check it, so log to the base 27 now of 1 over 81, and then squared, we should get that value. So just, you can hopefully see how you can plug this in, and that's going to give us a 16 over 9 as we expected. Yeah, so again, quite a nice little question and quite challenging. Right, okay, let's look at this one. I'm just going to rewrite this one. With this one, we've got now log to the base of 1/2, and then we got log to base of a half, and then we got the square root of 16. Now this needs to be positive, so that's going to be 4. So what power is 1/2 raised by to get 4? So if we write this now, 1 over 2 to the power of x is going to be equal to, remember we need the power. This is what we're looking for. We're looking for this value of x, and that's going to be 4. So rewriting these as powers of 2, what we'll have is 2 to the negative 1 raised to the power of x is equal to 2 to the power of 2. Therefore, we can say now that on here, let's just write this out, that x is going to be equal to -2. And that is what we get. Again, you might have been able to do that in your head. Perfectly fine if you have. But this is just a nice little way of doing it. We can write these as powers of 2. So if you wanted to, you could put in here, so log to the base of a half, or 0.5, of the square root of 16, which is going to give us now, hopefully if my maths has held up, -2, and that's what we get. So these ones are relatively easy, and these ones are, again, towards the end of the exercise, just to sort of stretch you a little. Right, let's see what else we've got. So there we go. Okay. In question 4, we're asked to find the value of x in the following. We're asked to give our answer to 3 significant figures where appropriate. Okay, we need to find the value of x. So all we've got to do is simply plug this in the calculator. So when you're doing logarithms, initially lots of the work will be manipulating using the laws of logs or basic evaluating. What we're now being asked to do is find a value of x. So all I'm going to do is simply plug it in the calculator. 3 to what power is 16? Well, 3 squared is 9, 3 cubed is 27. So this is going to be less than 3.5. So let's just put this in, and we'll have a look at what we end up with. Sorry, less than 2. What have we got? 2. Why did I say less than 3.5? 2.52. So 2.52. So 2.52. So if we did 3 to the power of 2.52, so if I just show the, let's just write this now. If I did 3 to the answer, now we end up with 16. Okay, next one. What we've got here is log to the base 6 of some value x is equal to -2. So let's go ahead and write the exponential statement. If we've got now log to the base 6 of x is equal to -2, we can say from this now, the logarithmic statement here, the exponential is going to be 6 to the -2 is equal to x. So with this one, we can see 6 to the -2 is 1 over 6 squared, so we're going to get 1 over 36, and that is what we'll have. If you want to rewrite it back, what power do we need to raise 6 by to get now 1 over 36? Well, the answer is -2. Check it on a calculator. It'd generally be a non-calculator problem though. So log to the base 6, so we need to write this out, 6 to the -2, so 6 to the -2 is going to give us that 1 over 36. Okay, next one, nice and straightforward, log to the base 4 of 9, so what we're going to do is just put it in. So log to the base 4 of 9, and that is going to give us now 1.58. So let's just jot that in. We got 1.58. So 1.58, and that's the 3 significant figures. Again, if you wanted to just check that, not that you really need to, if you just put 4 to this answer, so 4 and raise it to the answer, that is going to give us the 9. Okay, this one right here, we've got now got to find x, so we can just write this. It's going to be on here. Let's write this here. This is going to be 1/3 to the power of -2. Now that is going to give us 3 over 1 to the +2, and that therefore should now give us 9. If you want to check it, you can do, and you can simply plug it in. Again, I think this would be a non-calculator question. So we'd have now 1/3, which you could write as 3 to the -1 if you want. If you want to write this as 3 to the -1 to the -2 is 3 to the 2. Entirely up to you. So this is going to be now raised to the -2. Let's just put that in, and that gives us the 9. Okay, this one, very messy. 2.4 to what power is 13? We've got no integer value, certainly for that, or no tidy fraction. That is going to be quite messy. 2.93. So that one is 2.93. This one just here, all we'll do is now 4, so 4 to the power. Remember, the logarithm can be negative. We just can't take the negative, or can't take the value of a negative number to give a real value. So 0.17, 4 to the -0.17, 0.790, so 0.790 to 3 significant figures. Okay, last one. This one, we're trying to find the base. So if we just consider what we've got now, x squared will be equal to 16. Just think, the exponential equivalent, if log to the base x of 16 is 2, then what we can say from here now is that x squared is 16. So x is going to be equal to plus or minus the square root of 16. And then we can say now that x is going to be equal to plus or minus 4. X needs to be greater than 0, therefore x is going to be 4. You could have just spotted that. Log to the base 4 of 16 is going to be equal to 2. What value is raised by the power of 2 to give 16? The answer is 4. I think this would be a write it down question. Just write it down. But if you're unsure, all we need to do is put this in. Okay, so that's just looking at sometimes. The whole point of this particular exercise is to say that not everything's going to work out all pretty and nice, either integers or tidy fractions. Okay, let's just finish off with another question. We're asked to simplify the following. So what we've got here is log to the base p of p squared. We can later on look at the power law. I prefer to look at these as power law problems in terms of bringing the power down. For now though, we're not going to introduce that. I know that log to the base a of a is going to be equal to 1. So we can say now that log to the base p of p squared is simply going to be 2. If we look at this one, what we've got now is 3 lots of log to the base r of r to the 5th. Well, log to the base r of r to the 5th is just going to give me 5. Just go back to this right here. That's all we're going to have on here. So that's going to be 15. Okay, this one, log to the base 2 of 8 multiplied by log to the base p now of 1 over p. So if we just consider this one, and I'll just set up 2 brackets, log to the base 2 of 8, well, what power do we raise 2 by to get 8? That answer is 3. If we think about this another way, and it's entirely up to you, what power do we need to raise p by to get 1 over p? The answer is going to be -1. Alternatively, what we could do, and I'm not suggesting you must do this, is write that. So what we have then is 3 times by now -1, which is going to give us -3. So that's just some work to see whether a student would understand basic work with logs, and then we looked at a bit of evaluating. In later videos we'll look at the laws of logs, we will look at equations involving logs, we will look at solving equations that require logs. But that is basically the take-home message. So we've learnt what a logarithm is and how to evaluate them.